Fire.
Okay, thank you everyone for joining this presentation today, which is dedicated for software architecture standard for the software intensive system. And like it came from its definition, the software intensive system is such kind of system which are built over the many other subsystems, which requires integrated with third-party companies and service provider, which has a very complex data transformation, data management and manipulation, and very often is based on an advanced deployment model. So in fact, such kind of system constantly presenting very high risks in design, in construction and future evaluation. So it's quite important to attempt all of the risk on a very early age of the system development. And here the standard came to the scene. So why it's important to follow the standard? Because of it encapsulates best knowledge, best practice from a worldwide consensus from software architects around the world. And actually, this is the only one way for the stakeholder to make sure that the services and solutions they have developed for are actually doing the job we're intended to do. And so let's talk a little bit about the standard we have in IT domain. We have an open standard that's driven by a standard organization IEEE, which is the Institute of Electrical and Electronical Engineers, double-free consortium, and all the companies produce standards in a technical area which is widely accepted across all IT community around the world. The second type of standards are proprietary standards driven by leaders in domains like Oracle and Microsoft. And the third part of standard is an organizational standard developed by a certain organization for internal needs. And the standard we're talking today, it's called 1471. It's just a number in a sequence number from IEEE standard. It's delivered by Architecture Working Group in 2000, in September 2000. It's recommended for use. Right now, it's still under development. It still has some roadmap. And I know there is another number, 4021, which is overloaded as a standard, but it's still on the place. Actually, the standard itself, it's a big one and defines politics and defines so many stuff. And even the book I'm talking today, it has 500 pages, very useful information. So in the scope of our presentation, we are not going to cover all of that stuff because it's quite impossible. So we're going to focus on certain domains of the standards. It's the stakeholders and their concern, architecture view, architecture description, and system qualities. So let's talk about the stakeholders. Who is a stakeholder? Stakeholder is a person, it's a group of people, or it's an organization who have vital interest in the realization of the product. And why it's important to understand the stakeholder and their concern? Because of what we are doing in our life, we're doing for other people, and to be successful in our jobs, we need to understand what other people want and what they need. In software IT projects, we have certain list of stakeholders, so let's come from them quickly. First type of stakeholder is acquirer. Acquirer, or another name for it, it's a business sponsor. Actually, it's a person who invests its personal money into the project development. It's quite important. This is a key major stakeholder because all of you guys, includes me, got the salary because that guys put the money on the table. And this stakeholder has its own set of concerns, like project plan, like invest on return on investment ratio, like project costs, and business value. Right now we are working in offshore environment, and most of you, including me, have really a few chances to meet the business sponsor, even to find out his name in a documentation somewhere. But it's quite important to understand this guy is sitting somewhere and tracking his concern. Accessor, it's...
Sorry, one question here. So acquire is not in our world, in agile world,
product owner. It's not necessarily product owner, no. Product owner probably successor or communicator.
Product owner.
Product owner, yeah. Well, in a real world example, acquire, it's one guy who probably have no idea about agile at all.
No, but from the concern part, it seems that it looks like a product owner, because actually product owner does this. So he knows what he needs, he
Yeah, but
This is
puts the
someone
plans,
who acquires the
and so on.
system.
I hardly imagine the business sponsor sitting participating in agile meeting. So probably yes. So
Yeah, but
in my
in
experience,
such large project, there is no one person, there's groups of companies.
yeah, sometimes it's a group of person. Yeah, you're right.
Companies, not even persons, I think.
Okay.
Well, next type of stakeholder is accessor. Accessor, it's a guy who is actually it's from a real world example. It's an internal external audit. He is interested in your solution from a standardization point of view, from registration point of view, and actually, yeah, he's sometimes a jurist in the company. Communicator, it's a person who is responsible for delivering the value of the product to any other stakeholder. In a real world example, let's say we have two companies working together, joined together for delivering a product, common solution, and the communicator is responsible for running some training, some presenting materials for a major stakeholder in order to deliver project benefits. And actually, he's interested in business value of the product. He needs to understand rational reasons for this project. Yeah. I personally, well, all of that roles are probably sometimes can be split between one person, physical person. So next type of stakeholder is it's a developer, and developer actually interested in building your system on a very high standard, and we are, as a developer, very interested in documentation, in the functional specification, in the interface specification, in the way how we are going to build and deploy our solution, and so on. This is our concerns. Maintainer is a person who cares about our system while it goes live or goes to the production environment, and he needs to understand very specific thing: how to debug your application, how to monitor your application, how to control it, how to understand what's actually happening inside the application. Next type of stakeholder is a production engineer. Production engineer, we all sometimes call it as a deployer engineer. He's responsible for installing, migrating, and delivering certain patch and features to the solution. So he's interested in documentation, in installation and migration procedure, in software dependencies, in hardware specification. He's interested in the technical specification document because he needs to support all that stuff. Suppliers are guys who are delivering third-part solutions or services for us, and of course they're interesting that their product is installed correctly according all requirements and licensing issues. System administrator is a guy who is supporting IT infrastructure, and he's caring about support staff. It's not a secret that all good companies have a separate support department who provides incident management level 1, 2, 3, and by taking your solutions, they're interested in operational and support guide, troubleshooting guide. So some documentation in order to understand how to help users and to solve the problems. Administrator, it's quite similar with the production engineer, but they also interested in how to monitor your system, how to monitor performance, how to check availability, and so on. Testers and users. Testers, they're interested in testing the applications, they're caring in functional requirements, functional specification, interface specification, and so on. The users are mostly focused on functionality of the system, on the scope of the system, that the system is going to work as they expect and that it's easy to use.
Sorry.
Yes.
Where are the architects? stakeholders.
Here in architecture description, yeah.
No, but there you described all the stakeholders
Yeah.
in the system. Where are the architects?
Here in architecture description. So it's a I would say it's a person who serves all of the stakeholders.
But it's not a stakeholder.
I don't think so. It's a stakeholder. No.
Why it's not on technical side? Why it's not on development?
Well, to be honest, the role of the architect, according to the YASA course, it's a really wide. He has a really wide job description. So it's not only a technical guy. It's a guy who's running a lot of the stuff. So architecture.
Is a proxy for all of these stakeholders.
It's not a proxy. It's guys who actually delivering something which are servicing all the stakeholders.
Okay.
Do I answer your question? No,
No.
not yet.
Again, the question is the same. Why it's not part of the stakeholders? I think the architect is putting the most difficult decisions, and why it's not there? He's the first person to blame for some issues in the system.
Yeah. So
It's not a part of the system. It's overseen.
Yeah, that's why some of the architects do nothing, because they are not part of the stakeholders.
yeah,
Okay,
it's
let's
an
move on.
interesting conversation. Yeah. So we covered the stakeholders. So as I understand, as I mentioned before, in our short.
Sorry,
yes.
let me put differently. Can we deliver
Application
a
system.
a complicated system without an architect?
You can try. So the whole idea. So let me cover a little bit the architecture description idea. So probably it's answering your question. So why the standard is focused on a stakeholder concern? Because for all of the guys, as we saw from the concern, sometimes they have its own unique concerns, like deployment engineer, like a developer, and as from the other side we have some business owners. So all of them needs to have a common understanding of the system, and actually they are not interested in the concerns from other people. So and here we have an architecture description, which deliver a set of products that documents in a software and architecture in a way that every stakeholder can understand it. So here I have a diagram which illustrates this concept. So we have a list of the stakeholders. Every one of them has its own needs. We have a set of views. So what is a view? View it's a set of diagrams, set of documents which are focused on a specific concern. And we have architecture description document which builds everything together and provides a clear view on the final solution for all stakeholders. We have a functional view, deployment view, development view, operational view, informational view, and concurrency. Of course, some of the view on a great amount. So for a functional view, probably all of the stakeholders are interested in. For a deployment, probably just a system administrator and the deployer. But architecture description should have all of them.
Yep.
Okay. Again, about the view. So I'm going to cover every view, describe summary of every view, and we can later on go in the details. Functional view, information view, concurrency view. Both of them, all of them are mapped to the software structure and linked to the development view, deployment view, and operational view. I have a short table which summarizes the stuff. So functional view. Functional view is the most important one. Every stakeholder is interested in it. It's such kind of a cornerstone for the solution because it's defined actually the functionality of the system, and it's very close related to the functional requirements and non-functional requirements. It's focused on the functional elements, their mapping to the functional requirements. Also, it focused on the external or internal interfaces, on scenarios in the system. Next view is informational view, and actually it's focused on the way how your data is flowing in the application, how it's managed, how it's transformed, how it's stored, who creates the data, who destroys the data, who owns the data. So informational view is all about the data. Concurrency view, so in our modern days the majority of the projects are running in a multi-user environment as well. We have a lot of the background processes running in a multi-threading environment. So the concurrency view is focused on the way how you manage all of that stuff. How you're going to support multi-threading transaction management, how you're going to support multi-user access to your front-end application and so on. Next type of view is development view. Development view is described or focused on your internal structure of your solution and on the software development lifecycle processes, on the way how we're going to build, test, deploy our solution, how what type of standard we're going to use in our testing, in our testing and development, and a common design for our common stuff. Deployment view. Deployment view actually answering the questions how we are going to deploy our solution. It has a sometimes logical view, physical view. Logical view includes all your software dependencies, how you're going to manage them. The physical view contains technical specification for your server, for your network configuration, and some security stuff. Operational view defines the way how you control your application, how you monitor it, how you solve incident management, and actually some supporting stuff of your solution. Do you have a question at the moment? No?
So actually,
Yeah.
the viewpoints are a mind map for an architect to follow when starting a project.
Produce.
Sorry again?
So the viewpoints
Viewpoint, yeah.
are a mind map. You know the targets which an architect should find, not the target but the questions for which an architect should find the answers while starting a new product.
Yes. Every view defines set of domains, set of areas architect should attempt, should address, should develop some documentation in order to present it for the stakeholder for future discussion, for future investigation. Because, architect is actually it's not a person who make a decision. It's a person who can propose a decision based on some certain experience and maybe standards and reference to the previous activity. But everything is discussable. So. The main purpose of the architecture description is to present it to the stakeholder for discussions, because every stakeholder may find a set of interest in architecture description and try to understand, is it what the specific stakeholder is looking for? Okay, here we have a functional view. Functional view, as I mentioned before, it's a major one, it's a key view. So let's start with the functional capabilities. Functional capabilities, it's actually defines what the system is going to do and what is most important, which is not going to do. So here you need to define your scope. Here in your functional capabilities, you define your components, your architecture components, and you need to link it somehow to the functional requirements or non-functional requirements. External interfaces. External interfaces defines all interfaces, internal, external, for every functional component. So here we have REST, SOAP, TCP API, file transfer, and so on. So every type of communication needs to be covered in a separate documentation, separate specification with a very high details for all stakeholders. So. Internal structure. Internal structure is the way how you structure your application. It can be monolith, it can be multi-services, it can be event-driven application. All of that needs to be documented, and some decisions needs to be supported from functionality. So it's not a good reason to put a component into your architecture and say without any link to the software requirements. So if you have a big picture, architecture diagram on your board, you need to answer why these certain components appear on the diagram because of its link to some requirements, not functional or not functional. Sometimes some stakeholders may be interested just in functional capabilities. Technical stakeholder may be interested in design philosophy around your solution. So you need to be clever enough to explain why you have choose certain architecture and define your philosophy, like separation of concept, cohesion, coupling, and so on. This is a concern of the functional view. This is how many problems we have on this level. We have poorly defined interfaces or not defined interfaces at all. We have problem with outdated documentation for all type of data, like even for interfaces. We have here some elements like a God element. So like big, huge amount of functionality and who is doing everything, but it's not scalable at all. We have poorly defined functional requirements as well as non-functional requirements. So all of that issues needs to be addressed. Here we have examples of the functional, or else there is another name for context diagram. Here we have a functional model. Let's start with the first one. It's a very high-level diagram. It has a web browser, firewall. Here we have a solution inside the cycle e-commerce system. We have an order system. So by having this information, you have a clear idea how many components, high-level components inside your solution. This diagram provides more details, especially about the interface. So like here we have a user interfaces, we have a HTTP, we have a number of concurrent connection, we have another type of interface, RPC, we have some flow management here. These diagrams are not fine, let's say. They are just presenting the whole idea, but it's quite important that your solution, your architecture should have at least such kind of diagrams. Next type of diagrams and documentation for the functional view, it's functional element description. This table is it's very simple. In reality, there is a much more bigger table. So it provides description for let's say orders element. Its responsibility: manage orders, internal interface REST, output interface flat file. Of course, it's a very high level table, but you should have at least this table. And functional scenarios. Functional scenarios define at least a happy flow in your application. So here we have software components. We have an iteration between them, which demonstrates a happy flow. So again, functional view should have a description of all functional elements, description of all internal or external interface array at very high level of details. Description of the happy flow, exceptional flow, main scenarios in your application. Description, and everything in your functional view should have a link somehow to the functional requirements. Do you have questions for a functional view? Not yet? Okay, another view. Another view is informational view. As I mentioned before, information view is focused on the data, how the data came from your application, who creates the data, who destroys the data, who owns the data, what is amount of your data per day, per month, per year, how long are you going to keep this data in your database, or what is your database structure, how are you going to, how do you support your data quality, all of that answers. Questions answering this information view. Okay, let's start with the structure and content. The information view should define your database. Not database. How your data is structured. I mean, here usually we have a database structure. The flow. how data comes to the application, who creates this data, who destroys the data, how your data is accessed, how it is modified. For example, let's say we have a solution who operates with third-party companies, and data comes from that third-party companies, and sometimes it's not accurate, sometimes it's not validated, and actually how we're going to keep all of that stuff. Data ownership. Here, as I mentioned before, if we have a different source of information, for example, we have a company who sells something, and we have agents with laptops going to the client side. So some data, some set of information we have on the server side, some data inside the agent laptop, some data is on the client side. Sometimes clients call us and update information through the call center. Sometimes agents come to the main office and update data from the laptop to the main server. So you see so many different owners of the data. So you need to care about who has a primary priority, who has a less priority, which data should override some data, and so on. So all of the questions you need to answer here. How you synchronize data between different sources. How are you going to provide validation? Latency, agency, and timeless. Here you need to think about how old data you need to keep in your database. Usually we keep, usually we don't need to keep data for ages, for years. We need to operate with maybe 2-3 months data. Other data needs to be removed from system to the data warehouse, to the reporting system. Archives and data retention. Here we need to think about does losing the data will provide some registration issue for our company. Do we need to secure the data? How quickly we need to restore the data in case of issues? All of that needs to be covered in archive and restore policy. Data volume. We need to estimate how much data our application is working for in order to plan the disk space, in order to plan some infrastructure devices and infrastructure activities. It's quite important stuff. Data quality. Data quality, here we're talking about the data. So let's imagine a situation when you sell a product and you got a customer databases with all of the orders, the customer orders, and you need to build a marketing strategy over this data. So you need to find out which customer pay for something and so on. So by this case, you need to be very careful about your data quality in order not to achieve a wrong customer. So that data quality is also another way. Another very important domain, transaction management and recovery. Here we need to think how to manage our transactions, how many transactions we are going to run in the system, what is the hardware we need to have in order to support this amount of transactions, how we are going to support concurrent access to our data. A reference and mapping. Here we have, usually in our database, we have a huge number of objects from different sources, from different ownership. So we need to think how to uniquely identify each object. So we need to think about the uniqueness or reference ID for every major data. Otherwise, we will lose our continuity. Do you have any questions?
Yeah. Could you please elaborate more on data quality? I'm a bit fight about that.
Okay, so let me find out another example. Data quality, you need to think, so you need to have data quality, here you need to focus on equations I'm going to raise. So, for example, if you want to answer some question, how many customer order my product in the last year in a certain period of time from different countries for a specific customer age. So by having this information, I may build up my marketing strategy. But if I don't have answer, or even I have a wrong answer for these questions,
Sorry, what means marketing strategy?
Marketing strategy, okay,
It has
so
to do with the architecture of
So you mean
information.
okay, so it comes with data volumes as well. You must decide you keep big volumes of data
Mhm.
or you keep better quality details.
yeah, so for example, you are selling a product, yeah, across countries. You have a data warehouses, you have some agents. You got some information, some financial reports from all of that guys. Yeah, you accumulate everything in your database, but sometimes data may be inaccurate. So probably some agents provide you aggregated data, or wrong data, or data which is split with some other data. So by having this garbage, actually, you cannot do anything with that. So.
I got your idea.
Does this also address the case where, for example, the data is used in a redundant way in the system, is duplicated, we use the same data in different parts and it's copied all over the place and stuff like this?
Yeah, this is also the case. Yeah. You need, yeah, so we are keeping data for some reason. We are not keeping because of it came in our system. So we keep it for making some decisions, for running some reports, some analytical reports. So in order to respond some issues from a customer and so on. This is why we need the data. So we need to think why we need the data and keep it in a certain format. We can answer why. Okay, yeah.
One more question.
Yes.
Where exactly does the security concern, where are they addressed usually? In the information view or in the functional view mainly? Both of them or some
Both
other
of them,
place?
yeah. So yeah, as you work in a payment system, yeah, they are driven by PCI DSS security standards, which are very strictly about keeping personal data. Even personal data is not allowed to keep them for many other customers. So you don't need to keep personal data, account information, and some other stuff.
So this is concerning the data, but concerning the flaws and vulnerabilities that might appear in the system?
Yes, of course, it's related to information view.
Oh, okay.
Yeah, this is a stable summarize somehow what I actually said before. This is the problems we need to be very careful for. Data incompatibility. So if the data came from different sources, and we need to carefully define migration rules. Poor data quality, we're talking about this. Unavoided multiple decay, matching dependencies. Okay, interface. So it's a lot of problems. Right now, how many diagrams and products we have for supporting this information view? First one, it's a data structure. I think everyone is familiar with tables. Table structure has a table name, primary columns or important columns, and relations between tables. Well, usually it's quite difficult to support such kind of data structure view for a huge number of tables, more than several hundreds, because it became a really mess. So I really prefer to keep it small for every model. We need to have at least a separate table structure. Data flow. Data flow is a diagram which demonstrates the way how the data came and managed in our system. So we have here customers, warehouse, shipping, and order. So data came to the receive order. Here we run a validation. If it's invalid order, it's returned back to the customer. If no, it goes back. It goes to the system. So this is a specific type of data flow. Does anyone has an experience with or see at least once this flow? Yeah.
No, but it looks like decision tree. Decision diagram.
Well, it can be treated like a decision, but actually it says how the data is going through the system. if you got your payments and then you split it between two different streams, one of streams goes to the reporting, another stream is going to data enrichment, data management, transformation, so give you an idea how the data is flowing. Here we have, for some specific transaction, we need to define information lifecycle, how it's actually, what is important statuses of the data. Here we have transient, persistent, and detached. I believe it's from some Hibernate. Okay, any question? Not yet. Let's go to another next view, concurrency view. Okay, concurrency view. By the way, does anyone show the concurrency or similar type of view in your projects? Not yet, okay. The concern is about the concurrency view, task structure. What is actually task structure? It's a set of structure which is executed in a one-thread environment. So here you need to define what exactly your task is doing. Inter-process communication. If we have a situation when you have several processes running in the same box or split in different boxes and talking to each other through inter-process stuff like a pipe, like a TCP API socket, through the events or through some other stuff, you need to define all of that here. The inter-process communication. Startup and shutdown. Here we define the set of actions and execute it on a very first on a startup time. So probably your application needs to allocate some resources, needs to connect to the third-party services, needs to do something, and even in the shutdown process, you need to do vice versa. So you need to define it here in startup and shutdown. State model. State model is well, actually it's states of your data and state of your system. Concurrency model is defined the way how you're going to support multi-user access to your data, even for synchronization and integrity. So we have several diagrams here. First one, we have several processes, process 1, 2, 3, and we have a mutex here in order to synchronize access to the data. Usually, well, in my projects, to be honest, I don't specify all of that stuff because at the moment we have a ready-to-use framework, especially in the Java world, and we have application server who is doing the majority of the stuff. But as an architect, you need to define it somehow to say something about the concurrency. Another example is a state model. State model describes you the states of your application, how it's managed through certain events. To be honest, I probably never defined any concurrency view in the system. So do you guys have?
No, because
So
I
sometimes
think these are development decisions, and you must have clear idea of technical tech stack that you are using on the project as well on development patterns and right, Ilya?
Yeah, but there is a problem with concurrency and mainly data access. So that's the main concern. Yes, we have a lot of frameworks dealing with multi-threading and so on, processing. But how do we deal with data access? I don't know if this comes into architecture, but is it up to architecture to decide what to use?
it's up to architects to
at least or something
at
else?
least to document it. Yeah.
Okay.
Oh, deployment view. Deployment view is my favorite one. Okay, deployment view. Who is interested in this view? It's of course primary user for this view. It's a production engineer, system administrator, maintainer. The developer and tester also can be interesting in this view, and probably business owner is somehow interesting because of he needs to pay for all of this stuff. So what we have here in the deployment view, we need to define our software dependencies, the way how the solution is deployed to the server, the way how our network is configured, the way how we are going to run our application in a cluster environment or in a single node environment, the technical specification for servers, the RAM, operation system, version and upgrades and memory size, all of that stuff goes here in the deployment view. On these examples we have two sites, one site and another one, web server, database server, web server, database server, all of that going through the firewall. So this is also very high level diagrams, but it gives you an idea about how your system is deployed. Next type of diagram, it's a network model, in case if your application is a really complex one running in a distributed environment, and you need to define somehow your network configuration. So here we have several data centers connected through some very complex network devices and so on. Of course, it's a very high level stuff. All of that services needs to be described in a separate document, but you need to have at least this one. Any questions for the deployment view? Development view. Okay, here we have. We are, as a developers, we need to agree about the standards for design, code, and testing. We need to agree about the common design. I mean, for some stuff which are not related to functionality, like logging, auditing, monitoring, whatever. All that stuff goes here. Model structure, how we're going to structure our application. I mean, package diagram, how code line organization. Here we need to think about how we're going to keep our code, baseline strategies, the way how we build solution, how we test solution, how we deploy solution, and this is also covered in software development lifecycle processes. In the diagrams, I put just two examples of them. It's a package diagram, which display relation between internal packages and external one through the very high level package diagram, and software development lifecycle processes. We need to have this picture before we start the project, so it's quite similar for all projects. We have Jenkins, Sonar, dev environment, test environment, and so on. Any questions? Not yet? Operational view. Operational view is important for system maintainer, the person who is sitting and watching your application, supporting it in a live environment. Installation and migration. Every solution should have installation guide, the way how you're going to install applications, the way how you're going to migrate it from a previous version, code migration procedure, data migration procedure is going here. Operation configuration management. Here we need to have operational and support guide. I mean, here we need to cover all your informational and warning codes came from your applications. In order to just so let's imagine a support guy. He's sitting in front of a big monitor and he got a red alert with the error code 005. So you need to find out the operation support guide, open it to find out this error code with the short description, with the detailed description what he needs to do. We need to deliver this guide for him. Monitoring and control. Monitoring and control, good examples are Tivoli, or here we need to have to think about how we're going to inform other external system about what's actually happening inside our solution through logging, through auditing, through SNMP packages, through syslog. All of this goes here. Backup and restore. We need to provide detailed description for a maintainer. What is the best way to how he need to backup and restore our application. What is the certain things he need to do? Does he need to stop application before backup, or it's enough just make a hot backup of the database and so on. Migration. Migration, if our application requires some migration from previous version, we need to also provide details about that. Do you have any questions on operational view? Okay. Okay, so we're arriving almost to the last domain of the standards is system quality. System quality is there is another name for it. It's non-functional requirements. By IASA recommend to split all of the requirements in a three domains, operational related. Performance and scalability. So why it's important? So in general, why the non-functional requirements are important to understand? Because of they drives your architecture. For example, here in availability, you got 3 nines. You know, familiar with the concept of nines. So your system should be available 99.999% after the dot. So what is it for nines? It's let's say we have how many? 7 days per week, 7 for 24. It's about 160 hours per week.
Three nights, I think it's 5 days a year downtime.
Yeah. So yeah, in the context of the 1 week, it's how many hours? We have 160 hours per week. So our application needs to be available 155. So let's say 5 hours or 1 hour. So if you have 3 nines per 3 nines requirements, it means you need to have a cluster environment. You need to have some very advanced RAID and so on. But if the customer doesn't care at all about the availability, you need just provide just a general solution. Yeah, so all of the requirements are very important because they interfere to the architecture. Performance and scalability. Actually, I'm going to have another pass it on dedicated just for system qualities, but in the context of our current presentation, we can go quickly. Performance and scalability. It defines actually how many requests per second. So every business domain has its own metrics for performance. For payment systems, how many transactions per second, how many throughput per second. For other stuff, how many. For the other businesses, how many orders we need to process for a certain domain. Scalability, how scalable our application needs to be. Concurrency, how many users our application needs to support, how many concurrent transactions it needs to support, how many concurrent requests from external system we need to support. Availability, how available our application needs to be, how vital for our solutions is to be available 24 hours per day, let's say. Or it's not important at all, or our solution works from 9 to 7 every day. So this is a big difference. Usability, there is a huge topics about usability. We have a separate site, usability.org, with all stuff related to user interface itself and internationalization. Here it's focused on the usage related group. So here we answering how easy to use our application for the final users needs to be done. And support related, we have a security, evaluation, backup, and recovery. Do you have any questions for non-functional? So yeah, finally we are arriving to the end of our presentation. So let's do a small summary. What I'm going to say, there is a standards for everything, even for the software architecture. There is a standard for software architecture. It's not art, it's not what I think or other guys think. There is a standard. There is a certain things you need to do. If you don't have this in your projects, by knowing this standard, it's a good point for you to raise a red flag, to address the right person, to say, okay, you don't have this. For example, to architect in your projects, you don't have this. Why I need to have this? Because the standard defines this. So it's a good point to know. It's a good point to say something wrong in a project if the project missing all of that information, or at least the key views.
Yeah, Victor, but let's consider that this standard was introduced in 2000.
Yes.
Now we are 2017.
Well,
But we changed the approach on creating the product, agile.
Mhm.
But agile doesn't give the architects 1 year to develop all this documentation.
Of course not.
So how?
Like in agile practice. So as an architect, it needs to participate in all of your stand-ups, and he needs to deliver all of that architecture description through the set of iterations. It's not means, well, it was 2000, yeah, but it doesn't mean it was stopped in 2000. So there is a new version of this interface. It's 40 something else. So it's still under development. I will talk a little bit in his here.
Yeah, but we need.
What changes to the point of view we have since last 10 years?
It changes how this is developed and when. Because
I mean,
actually in
in
Agile, most of the times architects are producing this behind. So the product is done, developed and tested, then they do all these views and so on. Who cares about that?
Actually stakeholders do not invest money in documentation now.
But it's not only about documentation. It's
No, it's actually
About what?
it's about thinking. It's about designing what you're developing.
I want to
And
ask
how-
how many people
Yeah.
need to develop all this, because I had identified at least 7 persons with different knowledge to be able to put everything together. Now I agree that a project should not start without having all viewpoints, because we have the experience of shitty projects, yeah, where they have just the, let's say, development viewpoint, and that's it. No deployment, no other stuff, no data management, and usually these projects are pain in the ass, yeah, because nobody knows anything, or a person knows information based on his quick decision. After the person leaves the project, nobody knows how it works. I agree that all the projects should have this stuff, but Adrian is right. Now no one invests in the documentation. No one will pay you for 1 year or half a year to prepare all documentation.
It's not required so many times. So the project is not born in a minute, you know. And architect, it needs to be a big. It's important part to be a part of the discussions, and it's not a rocket science to deliver all of that stuff. So. And of course, it's not possible to deliver everything in one version once in time and just forget it. It's a iterative process. You need to have a draft for every view with simple words covering certain important concerns, just to make sure the main importance of the stuff, just to make sure that the solution is going to do what it was intended to do to understand by the stakeholders.
No, actually, it's a cool presentation.
Yeah.
I've never had an idea that this kind of standards exist.
Yeah. So if you think your project is missing some information, or you need this information,
My project
You
is
can-
missing a lot of information.
you can raise your hand, you can raise alert and say this information is missing and it's required because so there is a standard, international approved standard that it says it should be done, you know.
Another point of view is that once you see the missing of such parts just hurting the value of the product you do, and the most important thing for business might be the value, what the solution is solving. And if this is somehow just preventing the solution to deliver a value, that means that this is something that have to be produced or delivered as well as the part solution. Knowing all this catalog just provide you a ground base for just having a structured conversation between business and other stakeholders to manage that, to include into scope. Yeah, I mean, I believe this is the main point of having such catalog and just holistic view on a system you are working on. It's probably for some project it's worthless, but for some, if it's comparing the value, why not?
No, actually, for all the projects, it brings a lot of value to the table.
Yeah, value is value is the utility just in perception of stakeholders. As if there are nobody who perceive the utility and just say that this is nothing, that's not a value. Value starts when the stakeholders say, yeah, this is something can save me money or can deliver something more to the product or can just help us with this and that. That means they feel the value and they see they can build the case. Once nobody believes in that, it just means it's bullshit.
About the future reading, what you can do. There is a standard available on internet. You can find it or you can ask me and I have all of that information. I am highly recommended just to take a look on this book. Working with stakeholders using viewpoints and perspectives, second or third edition at the moment by Ion Wood and Nick Rozansky. You can search in the internet and find out the electronic version of this book. It's available somehow. They also have a dedicated website, Viewpoints and Perspective. It's driven by also Ion Wood and Nick Rozansky, and which is good. The site has a set of templates ready to use, so you can download template, architecture template. I can show you probably, and just put your data here. There is another site, it's Architecture IEEE. It has all information about the standard, about the history of its development, about the current state, and it also has templates. So my recommendation is just take a quick look on the standard itself and take a quick look on this book. And probably you need to take a quick look to the templates. I can probably.
Can you send us this?
Yeah, of course. So this is a.
It's attached to the invite.
Да?
Not to invite to the link in the learning site. It's there.
So this is a template delivered by Ion Wood. It has stakeholders, requirements, architecture forces, and architecture views. So let's go quickly from them.
Sorry, thank you.
Yes, okay. So you can do it by yourself, but what I'm going to do is that pay attention on architecture view in a section. It has a present functional view or context view. It has a scenarios view, functional elements, description of every element, scenarios, information view, data structure, data ownership, who owns the data, information lifecycle. So all of that stuff are here. So it's a good news. So just download the template, and if you're interested, just put your information there. Okay, I think it's all for today for this presentation. Thank you very much again for your participation.
Thank you.
Okay, thank you.
There is a forums.